Okay. February, March 2020, paper 6, variant 2. Question 1. A student is determining the density of wood by two methods. In method 1, he will measure the length, the diameter. Okay. First of all, we need to measure the length of this wooden rod, and we need to measure the diameter as well. Using the ruler, we can measure the length and the diameter. Definitely, your measurements, I know your measurements could be a little bit off. Why? Because as we know that the printing usually diminishes the size just a little bit. So the initial reading was, I guess, 4.5 centimeters for the length and 2 centimeters for the diameter. Okay, 4.5 centimeters and 2.0 centimeters for the diameter. But again, your readings could be 4.3 or 4.4, 1.9 or 1.8 for the diameter. It's not wrong. It has to do with the printing. That's it. Okay. Um, Next question. Suggest an accurate method for measuring the diameter of the wooden rod in this experiment. List any additional apparatuses you might be required and briefly describe how you determine the diameter. Can anyone help me out? How can we measure the diameter a little bit more accurately? Any ideas? This is one of the very famous methods. Hmm. Hmm. Yes. Hmm.
احنا ممكن نحطه between two wooden blocks مثلا ونmeasure
Yes.
the
E-
wooden blocks.
Exactly. Hmm. Uh, okay. بالظبط. Do you have any other suggestions? Hmm. Yes. Okay. Then put or place the wooden rod between two wooden blocks. Yes, this is the wooden rod. Place it between two wooden blocks. These are two wooden blocks. Uh, Place the rod between two wooden blocks and measure the distance between them. The distance between them. Okay, it's quite easy. Okay, it's a very commonly used method. Okay, this is a very commonly used method. So please try to remember it, inshallah. Record the mass of the rod. I guess this is quite easy. You can record the same um, mass. Okay, and then I can measure or I can calculate the density. Mass is 7.8 grams. Calculate the value for row 1, density of the wood, using your values. Row 1 equals 4m over pi d squared L. Include a suitable unit. 4m, 4 times 7.8 over. 4 times 7 point over pi d squared. D was, I guess, 2.0 and 4.5. Okay, times 2 squared times 4.5. Okay, can someone help me out? Hmm. It should be, I guess, around 0.55, if I'm not wrong. 0.55.
ايوه صح.
Okay, 0.55. What's the unit of the density? Hmm. That's the question. What is the unit of the density? Huh. Yeah, the second mark should be grams per centimeters cubed. Correct. Grams per centimeters cubed. Yeah. Moving on to method 2, the student pours water into a measuring cylinder. Hmm. Meter. لا, it's not meter. It's grams per centimeter cubed. Why is it not meters, not meter cubed? Because the initial length and diameter were in centimeters. Okay, so the unit, the density has to be in grams per centimeters cubed. Okay, it cannot be grams per meter cubed. Okay, that would be wrong. حلو. The initial V1 was 144. Yes, that is correct. V2, no, it's not 151. Hmm, this is 144. Uh, V2 would be 152. 152. Yes. Okay. V1 and V2, so I can find the difference in the volume. Yes. Can find the difference in the volume of the quark. The student removes the rod and lowers a piece of modeling clay into the water as shown. V3 was 164 and then V4 was 178. Calculate another value for row 2 for the density. Okay, use the values of CD. Okay, V2, V1, V2 minus V1 over V4 minus V3. Okay, that's quite easy. V2 minus V1 was 152 minus 144. Yeah, that's easy. Someone calculated for me. Yeah, 152 minus 144 over, well, V4 minus V3, 178 minus 164 times K, which is times 1, basically. Okay, it would be 0.40. hmm, No, not 0.40. No, no.
طلعت معايا 0.57.
0.57. Yes, that is correct. 0.57. And again, the unit of the density would be grams per centimeters cubed. Density. You're finding the density grams per centimeter cubed. Okay, so row 1, okay, density 1 was 0.57, and then 0.55, and density 2, row 2 was 0.57. On figure 1.8, draw an arrow showing the correct line of sight reading in the measuring cylinder. Again, the correct line of sight would be perpendicularly and from the bottom of the cylinder, from the bottom of the meniscus, uh, bottom of the meniscus, perpendicularly, straight line using a ruler. Okay, and this is the eye from the bottom of the meniscus. A possible source of inaccuracy in method 2. One possible source of inaccuracy in method 2 could be what?
Parallax error.
Parallax error. Um, Not really. No. Hmm. hmm. What other sources of inaccuracies?
Not taking the reading perpendicularly.
Well, it's the same answer basically, which is not 100% right. Okay.
عشان الواتر بتكون عندها curve في السايد.
Okay, curving on the sides. Okay, the same. It's again, someone's saying you didn't take the reading perpendicularly, there's a parallax error. Okay, you're saying you didn't take the reading from the bottom of the meniscus. Again, it's okay, but it's not 100% correct for this answer. Okay, for this answer, one of the possible sources of inaccuracy would be, for example, okay, for example, in figure 1.6 and figure 1.7, we use the modeling clay. So you put a modeling clay. While removing the modeling clay from the water, you could remove some water while taking the modeling clay out. Okay. Or, for example, this is a cork, this is a wooden cork. This wooden cork could absorb some water. So in removing the wooden cork or removing the modeling clay, it could remove some of the water. So the reading wouldn't be 100% accurate. That's one possible source. Again, this is a 1 marker. Okay, this question is worth 1 mark. Would it be um would it be the best choice to spend too much time on this answer or on this question, no, it wouldn't be the best choice to spend too much time on this question. What should you do? If you do not know how to answer this question, just leave it and come back later and then solve it. Okay, it's worth only 1 mark. Okay, probably if you had written down the answers, you didn't take the reading perpendicularly, or you didn't take the reading from the bottom of the meniscus, or because the water was curving, or whatever. Okay, probably you would have taken the mark, probably. Okay, but again, there are better answers. That's what I'm saying. There are better answers for this question. Is it logical to spend that much time on this question? No, it's not. Okay, it's not logical to spend that much time on a question worth 1 mark. So just leave it and then come back later. Again, one possible source of inaccuracy, you could lose مثلا um, while uh, while removing the clay, water was also okay taken or was also removed from the measuring center. Okay. Again, you can also say that the cork or the wooden block absorbed some of the water. That's why the reading of the water wasn't 100% accurate. Okay. Yeah. Moving on. Question 2. You have a thermometer. Record the room temperature. The room
21.
21. Again, don't forget to use the unit. 21 what degrees Celsius? 21 degrees Celsius. Okay. Um, we have a table. Okay. Temperature and time, temperature. Describe one precaution that you would take to ensure the temperature readings. Yes, someone said stir the water. Correct. This is 100% correct. Yeah. Stir the water gently before taking the reading. Correct. Okay. Again, you skipped one question. Look, you skipped one question. Complete the headings. It's worth 1 mark. Do not forget this. Complete the headings. Complete the table headings. T
Seconds or
slash
degrees Celsius.
seconds and theta degrees Celsius. Yes. Okay. Seconds and degrees Celsius. Calculate the average cooling rate, x1, during the first 90 seconds of the experiment. Theta 0 and theta 90 over t, where t is 90 seconds. T is 90 seconds. Theta 0 and theta 90. What are the numbers for theta 0 and theta 90? Any ideas? Yeah, theta 0.
95, 95 or 79.
Yes, 95 and 79. Yes, 95 and 79. So 95 minus 79 over 90. Can someone calculate it? 95
0.17.
over 90, that would be yes, 0.1.
Seven.
It's not 18. It's 17 something. 0.17. Okay, it should be 0.18. What's the unit? Do you know the unit?
Degrees per second.
Degrees Celsius per second. Yes, thank you. Degrees Celsius per second. Again, can I calculate theta 90 and theta 180 over t? Again, t is 90. Theta 90 and theta 180. Yeah, theta 90 is 79. Theta 180 is 68.5. 79 minus 68.5.
0.12.
Okay, over 90, it would be 0.12 degrees Celsius per second. Degrees Celsius per second. Theta 118 to 70. 68.5, 62.5 over 90.
0.07. 0.07.
Okay, 0.3 Celsius per second. Thank you. The temperature of the water falls as time passes. Use the results from C to describe the pattern. Describe the pattern and justify your answer. Any ideas?
As time passes, the rate of cooling will decrease.
As time passes, the rate of cooling does decrease. This is correct. Okay, but we have to justify with numbers. How can we justify with numbers? For example, in the first 90 seconds, x1 was 0.18 degrees Celsius per second. x3 was 0.07 degrees Celsius per second. Okay? Yeah, as time passes, let's write it down. Sorry. Ugh, I hate it when the pen does this. As time passes, the rate of cooling decreases. For example, in the first 90 seconds, the rate of cooling was 0.18 degrees Celsius per second. Okay, in the last 90 seconds, the rate was 0.07 degrees Celsius per second. Again, when he says justify, whenever he says justify, you have to write down numbers. You have to use numbers from the table or from whatever previous question. Okay, you have to do that. Give an estimate of the possible final temperature theta F of the water if left to cool for many hours. Okay,
21 degrees.
21 degrees. That is correct. Okay. If the water was left to cool for many hours, it eventually must reach the room temperature. The final temperature has to reach the room temperature. Okay. Um, okay. A student in another school carries out similar experiment. She starts with the hot water at a lower initial temperature. Someone was asking, how did we know? How did we know that this is the room temperature? We found out the room temperature initially. Initially from the graph, we found out the room temperature, theta R, was 21 degrees Celsius. So eventually, if you have some hot water and you let it cool, it will reach the room temperature after whatever amount of time. Okay. A student in another school carries out a similar experiment. Okay. But the only difference was that she started at a lower initial temperature. Suggest how her cooling rates are likely to compare with those calculated in C. How would her cooling rates compare with those in C?
cooling rates هتبقى أقل.
Yes, cooling rates would be definitely less. Okay. Cooling rate would be less. Why? Because hmm, as the temperature, as the temperature of the water gets closer to the room temperature, The rate of cooling, rate of cooling decreases. Okay. Yes. State one variable other than the initial temperature, which the student could control.
Volume of water.
Volume of the water. Yes. Okay. Volume of water. Right. Hmm. Yeah. We have a circuit, voltmeter and ammeter. Take the reading of the voltmeter and the ammeter, and then measure the resistance as usual. Voltage is
2.1.
yes, and the current is what's the reading of the current?
0.26.
0.26. Yes. Okay. 0.26. The resistance 2.1 divided by 0.26 would be
8.1.
8.1 ohms. Okay, حلو. The student then connects the crocodile clips to different lengths and she measures the current. Can I find 1 over I? Can you calculate 1 over I? Hmm.
2.9.
Hmm. Okay.
2.9.
2 لا, do not write it as 2.9. Why? Don't write it as 2.9 because all of the other numbers, all of the other values are in three significant figures. Okay.
2.86.
2.86. That is correct. Okay. Can I plot a graph? Yes, I can plot a graph. You do not need to start your axis from the origin. Okay. I need to plot the graph. L on the y-axis, okay, L slash centimeters on the y-axis, 1 over I slash 1 over A on the x-axis, okay, quite easy, 1 over I slash 1 over A on the x-axis. You do not need to start your axis from the origin, ماشي. The length 70, 60, 50, 40, and 30. Okay, we can start off 30, 40, 50, 60, 70. I, or 1 over I, okay, 1 over I. How can I plot 1 over I? Or how can I, hmm, how can I scale this graph? Hmm.
ممكن نبدأ ب1 و moving by 0.5.
We can start off with 1 and 0.5. Okay, let's try it. 1, 1.5, 2, 2.53. That's it. That wouldn't be actually the best choice. Okay, it would not be the best choice if you started off this way. Okay. Hmm. What else? What could I do? I need to start from 1.54.
ممكن نمشي 0.
Uh, uh, say again?
نبدأ ب 0.20.
0.20. Okay, let's try 0.20. I'll start off with 1.5, 1.7, 1.9, 2.1, 2.3, 2.5, 2.7, and 2.9. Okay, that is actually really good. Okay, that's quite excellent. Thank you. Okay, 1.5, 1.7, 1.9, 2.1. That is Excellent. Why? Because we'll start off with 1.4, which would be somewhere here, and we'll end up with 2.86, which would be somewhere around here, which is excellent. Someone suggested that we use the numbers in the graph, in the table, which would be wrong. If you use the numbers in the table, that would be wrong. Why? Because these numbers aren't separated evenly. Okay, the difference between each number, it's not the same, so you cannot do that. Okay, you cannot do that. Okay, yeah, let's plot the points. Let's plot the points. Yeah, let's zoom in and start plotting the points. First point is if you want to start wherever, 31.54. 30 and 1.54. بصوا هنا this is 1.6. This is 1.6. So each small square is worth 0.02. So 1.54 would be two squares, okay, after 1.5. Okay, two small squares after 1.5. This is 1.54. And then 1.89 and 40. 1.89 and 1.40 here. 2.27, 50. 2.27, 50. Okay, this is 2.2, 2.20, 2.22, 2.24, 2.26, 2.27. 2.50 and 60. Okay, it's quite easy. 2.86 and 70. 2.86 and 70 would be 2.80, 2.82, 84, and 86. Okay. Yeah, let's draw a line of best fit. I guess he needs a gradient. Yes. Okay. Okay. Yeah. Let's draw a line of best fit. Straight line. Mhm. This would be the best fit. Okay. This is the line of best fit. Okay, quite easy. How can I find the gradient of this line? Okay. Gradient is rise over run. It's the slope. Okay. How can we find the slope or the
y2 minus y1 over x2 minus x1.
over x2 minus x1, which is correct. But you must again for the 100th time, you have to use the triangle method. What do I mean by the triangle method? You have to connect a triangle or draw a simple triangle, okay, on the graph. If you do not draw the triangle, you will lose a mark. Okay. Yeah. And another line, a vertical line and a horizontal line. And then you will calculate y2 minus y1 over x2 minus x1. But if you do not draw the triangle, you will lose a mark. y2
Mr.
minus
Fahna, do we need to use the first and last point?
not necessarily the first and last points, but you need to use very distant points. Yani, if I use, for example, these two close points, for example, if I take this point and this point together, it would be wrong. You have to use very distant points. Okay. Like, for example, you can use the second point and the last point. مثلا. It would be correct. Yeah, y2 minus, sorry, y2 minus y1 over x2 minus x1, that would be 70 minus 30 over 2.86 minus 1.56. Yeah, I'll remove the line.
مش هي 1.54
1.54. 1.54.
تبقى 30.3.
70 minus 30 over 2.86 minus 1.54. It would be
30.3.
30.3. ماشي. Okay. 30.3. Calculate the electromotive force, EMF, of the power supply, user values. Yes, I can use that. G times R note, where R note, user value of R note. Where's R note? No, which was 8.1. 30.3 times 8.1 over 30.3 times 8.1 over K, which is 100. Can someone calculate it for me? يلا quickly يا شباب.
2.45.
2.45 volts. The ammeter in this circuit has a small resistance which affects the current. The effect of this resistance on the measured current will be different for each measured length L of the resistance wire. State and explain which length L will be most affected by the resistance of the ammeter. Which length? This is an interesting question. Which length would be the most affected by the resistance of the ammeter, and why? Any ideas? Someone said 30. Okay. Why? Question is why? Okay, if you say 30, if you say 40, 57, you have to justify. You have to tell me why.
عنده the
عشان
low
أكبر
screen.
لينس.
Anyone, please. يلا قول.
عشان كل ما اللينس بتنكريز الريزيستنس بينكريز.
So your statement would be 30 ولا 70 ولا ايه؟
70.
70? طب what about you?
70
70?
عشان inversely proportional.
طيب. Actually it's not 70. Okay? It is 30. The question probably you just didn't read the question correctly. Okay? Just try to read it again. Very simply, the ammeter in this circuit has a very small, it has a small resistance which affects the current. It does affect the current. Okay? If it does have a resistance, it might affect the current. The effect of this resistance on the measured current will be different for each measured length. Okay, it would be different for each measured length. So the ammeter has a resistance. This resistance could be insignificant, okay, and it could be significant. It could be significant or insignificant. It depends on what? It depends on the percentage of error it would create. Again, it would depend on the percentage of error it would create. If I have a resistance, let's say, if I have a resistance of 3 ohms, for example, if the resistance of this ammeter is 3 ohms, would 3 ohms affect the 30 centimeters more, or would it affect the 70 centimeters more? Definitely, it would affect the 30 centimeters more. Why? Because the 30 centimeters has a small resistance. So if you have a 3 ohm resistance affecting the small resistance, the percentage would be greater. Okay, just try to calculate the percentage. The percentage of resistance, the percentage of error would be much greater than if you are measuring or if you are calculating the resistance or trying to use the 70 ohm resistance again. Okay, let me give you some numbers. The 30 ohm, the 30 length, the 30 centimeters and the 70 centimeters. This had a current of 0.65 and this had a current of 0.35. He did not give you any resistance for this question, but you can say, for example, 30 ohm resistance, the 30 centimeter length had a 30 ohm resistance, for example, and the 70 centimeter had a 70 ohm resistance. Okay, if I say that the a meter has a resistance of 3 ohms. Okay? If it has a resistance of 3 ohms, then the percentage of error it would create for the 30 would be 3 over 30, which would be about around 10% error. Okay? But the 3 ohms, how much does it affect the 70 ohm resistance or the 70 centimeter length? I'll calculate it. 30 or 3 over 70, which would be less than 5%, I guess around 4% or something. Okay, it's around 4%. So the percentage in error, okay, the error would be much less. That's the whole point. Okay, it would affect, okay, it would affect the 30 centimeter much more than the 70 centimeter. That's the whole point. Okay. I hope you got it. Does anyone not understand it? Which length would be the most affected? The 30 centimeters. Again, the 30 centimeters, okay, has the shortest length, meaning it has the least resistance. Okay. If I add some more resistance, 3 ohms, whatever resistance this ammeter has, would affect it that much? Yes, it would affect it that much. Why? Because of the percentage error. Okay. Do you remember when we talked about, for example, the pendulum? Okay. Why did we leave the pendulum for 20 cycles, for 30 cycles? Why was 30 cycles better than 5 cycles? Why was 30 cycles better than only 1 cycle? Why? Because there was a percentage error. Okay. There was a human error. This human error, okay, it was constant. For example, it was 0.5 seconds. It was a constant error. Okay. How can I decrease the percentage of this constant error? How can you decrease the percentage of this error? By increasing the number of cycles. In this case, how can you decrease the percentage of error for the ammeter? By increasing the length. So if I had a length of 100 centimeters, for example, would that have an even better, okay, or an even less percentage error? Yes, it would have a less percentage error. And that's the whole point. Okay. Yes, 30 centimeters would be definitely the most affected. Why? Because the percentage, okay, um, it would have the greatest percentage of error. It would have, okay, the greatest percentage error. Okay. It's proportion. It is a proportion. Yeah, moving on. Planning an experiment. Okay, student investigates a wind turbine. Electrical generator driven by a propeller blade. Okay, plan an experiment which will enable him to investigate how the current and the resistor connected across the terminals of the turbine varies with the speed of the air flowing through the turbine. How does the current vary with the speed of the air flowing? You have some apparatuses, model wind turbine, electric fan, a device for measuring the air speed. Okay, in your plan, you should list any additional apparatuses, complete the wind circuit. Okay, state any key variables. Okay, again, what is this student doing? What is he doing? Basically, he is changing the speed of the air flowing and then measuring the current output. That's it. That's all he is doing. So the variable or the range of values, the thing that he will be, the independent variable would be the speed of the airflow. That's the range of values. That's the thing he will be changing. For example, range of values. Range of values. Okay. What is the variable he'll be changing? What is the independent variable? The airflow, okay, or air speed, for example, air speed or airflow. Okay, this is the variable he will be changing. Okay, for example, he has several speeds. Let's say 1 meter per second, 2 meters per second, whatever, it doesn't matter, okay? 1 meter per second, that's the speed of the air, for example. 2 meters per second, 3 meters per second, whatever. 4 meters per second, 5 meters per second. This is the speed of this fan, okay? Can I complete the circuit? Yes, I can definitely complete the circuit. This is quite an easy circuit. How can I complete the circuit? Okay. The only missing thing in this circuit is what is an ammeter. You need an ammeter. Why? Because he is measuring the current. Okay, and you can just complete the circuit. That's it. That's it. Okay, you've just completed the circuit. It's quite easy. You needed an ammeter to measure the current and just complete the circuit. Wow. Additional apparatuses. Additional apparatuses is the ammeter, quite obviously. Okay. Additional apparatuses is the ammeter. Okay. And that's it. Yeah, apparatuses. Okay. Key variables. I can write down the key variables first, and then I can write down the apparatuses. Okay. First of all, the key variables or the variables that I will keep constant in this question. What are my key variables? Key variables. Can anyone suggest some key variables I can use in this question? Some constants, some controlled variables.
ال distance between ال electric fan وال propeller blade.
Yes, that is correct. Any other key variables? Distance between the fan and the blade. Hmm. Okay. Someone could say, for example, the height. Okay, the resistor. Resistor is not wrong. It's not wrong. Okay, but يعني, if you want to write it down, it wouldn't be wrong. If you want to write it down, it would not be wrong. Okay, I'll say, for example, the height of the electric fan and the propeller blade. The height of the fan and blade. Okay, range of values, key variables, the apparatuses for this question. Definitely, you need, as we said, apparatuses. We definitely need an ammeter. Okay, ammeter to measure the current. Um, okay, that's quite easy. So we finished up the additional apparatuses, the key variables. Can I state briefly how I would carry out this experiment? Yes, and then I will need to write down a conclusion. I do not need to draw a table for this experiment. Okay, he did not state clearly that I need to draw a table, so I don't have to. Okay. Yeah. What's the method? What are the steps that I will be conducting for this experiment? Method, quite easily. For each air speed, for example, for each air speed, what will I do? Measure the current, okay, or record the current. Record the current in the ammeter. Okay. And then you have to say, repeat for each of the other speeds. Okay. You must say that. Each air speed, record the current in the ammeter, repeat for each of the other fan speeds. That's it. Literally, that is it. That's the whole method. Okay, you do not have any more details you need to write down. Okay? That's it. As for the conclusion, okay, as for the conclusion, all you'll have to say for each, okay, you do not need to write down a table in this question. In this question, you do not need to write down a table. Okay, for each airspeed, repeat and take average. Okay. Usually we say record the readings in the table. No, you don't have to record the readings in the table. You could, for this question, say we'll plot a graph, for example. Okay. Instead of writing down the answers in the table, you can, okay, plot a graph. Okay. Plot a graph for the independent variable should be on the x-axis and the dependent variable should be on the y-axis. For example, for the airspeed on the x-axis, and the current on the y-axis. Okay, that's it. Okay, repeat and take average. Plot a graph, compare the results. Okay. Compare the results. That's it. That's it. Okay.